Hello students, now let us see the next theorem, that is factor theorem, from the topic polynomials. Now this factor theorem is the theorem which is derived with the help of the remainder theorem. So remainder theorem and factor theorem are uh, are interlinked with one another. Now let us see what does the theorem say. It says if p of x is any polynomial where the degree of p of x is greater than or equal to 1. Now this was the same condition when we had seen the remainder theorem, that the degree of p of x has to be greater than or equal to greater than or equal to 1, and if a be any real number, then x minus a is a factor. Now x minus a was the divisor when we had checked the remainder theorem. So it says x minus a is the factor of p of x if p of a is 0, or if p of x is 0, then x minus a is a factor. Now let us try to understand the theorem. First of all, let me write down the remainder theorem. Now according to the remainder theorem, what was the change in our division formula? Divisor, which was p of x, is equal to dividend is equal to divisor into quotient plus remainder, right? Now whenever we had seen the remainder theorem, we had taken the divisor to be of the form x minus a, and the remainder we had got, which was a constant, so p of a equal to r we had obtained. So what was the remainder then? P of a. Okay, so by remainder theorem we have got this division algorithm. Now let us see, according to the condition, our remainder theorem we have obtained, and which is applicable to this itself, where p of x is a polynomial degree greater than equal to 1 and a be any real number. It means x minus a is the divisor. It says if p of a is 0, then x minus a is a factor. So in this case, if p of a is 0, what will be the change in the equation? It will get p of x equal to x minus a into q of x, meaning you are getting the dividend, the divisor, and the quotient, right? Did you get the remainder? No. Now first of all, let us see what is meant by factor. Now you have learned this concept. What is a factor? A factor is something which divides the equations. Or suppose if I say, I take the number 16 and I say check if 4 is factor of 16 or not. Now whenever I say check if 4 is factor of 16 or not, it means I will divide 16 by 4, and if I get the remainder as 0, or if it is completely divisible, then I will be saying yes, 4 is a factor. But if I divide that 16 by 3, will I get the remainder as 0? No, it will be 3 5 is 15, the remainder will be 1. So in this case, 16 is not completely divisible by 3, and hence 3 is not the factor. So what is the concept of factor? Factor is to be said only when the remainder is 0. And here we have obtained the remainder to be 0. And hence I can be saying that since the remainder is 0, so yes, x minus a is the factor of p of x. So we have proved the first condition, that if p of a is 0, then x minus a is the factor. Now let us see what is the second condition. It says p of a is 0 if x minus a is the factor. Now in second case, taking the same remainder theorem, because factor theorem is applicable with respect to remainder theorem itself. So taking the same remainder theorem, it says if x minus a is a factor. So if x minus a is the factor, let us put x equal to a in the equation. What I will get? This will be my p of a, and here it will be a minus a into q of a plus p of a. So what am I getting? Yes, as you can see, here actually we write only q of x. Yes, as you can see, I will be getting p of a as to be 0. This P of A is already 0, therefore A minus A is 0, and hence I will be getting P of A is equal to 0. That is what is specified in the second condition. It says if x minus A is the factor, then P of A is 0. So if I have taken x minus A to be the factor, I have got P of A is to be the 0. Okay, so factor theorem and remainder theorem applicable to one another. We can prove factor theorem only with the help of the remainder theorem. Let us revise. It says if p of x is any polynomial whose degree is greater than equal to 1, and if a is any real number, so if x minus a is the factor, when it will happen? If the remainder is 0, and if the remainder is 0, then it is the factor. Now what kind of questions could be asked from the factor theorem? Yes, suppose they give you one polynomial and they might ask you find the factors of this polynomial. Okay, so x square plus 2x minus 15, the same example, and the question asked is find the factors of the given polynomial with the help of factor theorem. Now we had find the factors by splitting the middle term theorem method, but since they are specifying you have to make use of the factor theorem, so definitely we have to follow the theorem. Now according to the theorem, it says for whatever values of x, if you are getting the given polynomial to be 0, it means that will be the factor. Yes or no? If p of a is 0, then x minus a is the factor. So let us check. If I take p of 1, what I will get? Putting x equal to 1, so it will be 1 plus 1 minus 15, which is equal to minus 13. P of minus 3 I am directly taking. So it is minus 3 square is 9, minus 6 or plus 3. 9 plus 6 minus 15, which will give me a 0. What does it mean? It means this has become my value of A. So if P of A is 0, it means if P of 3 is 0, what is the factor? X minus A. So x minus a means what? It will be x minus 3. So which is the first factor of this polynomial? It is x minus 3. Similarly, if you take x equal to minus 5, so it will be p of minus 5, which will give me 25 minus 10 minus 15. Again this is equal to 0. So I will write x minus a should be the factor, so it will be x minus of minus 5, which will give me x plus 5. So which is the another factor of this polynomial? It is x plus 5. Okay, so this is how you have to use the factor theorem whenever you have to find the factors of the given polynomial. Taking different values of x, wherever you are getting it as 0, it means that will be the factor. Okay, now what are the second type of questions they are asked? Here equation was given and factors had to be found. Now directly they might tell you that yes, it is a factor. Suppose x square plus kx minus 15 is my equation, and they are saying x minus 3 is the factor of this polynomial, find k. Okay, according to the factor theorem, if any linear polynomial is a factor, it means the remainder is 0, or taking the 0 of this and putting it. So if x minus 3 is the factor, so definitely p of 3 will be equal to 0. Put it in the equation. P of 3 equal to 3 square 9 plus 3k minus 15 equal to 0. Therefore, now what is 9 minus 15? I will get it as minus 6 plus 3k equal to 0, which will give me 3k equal to 6, and value of k has to be 2. So what will be the equation now? X square plus 2x minus 15. So as you can see, yes, here I had already find the factors, so I have made use of this same example so as to help you understand. So These are the two types of questions they might ask you. They might give you one example and they might ask you to find the factors. In that case, you have to make use of the remainder theorem. Wherever the value of x turns out to be 0, that will be the factor of the given equation, or else they might directly tell you that so and so linear polynomial is a factor of the so and so linear polynomial is a factor of the given equation, and you have to find the unknown present in the equation. If it is a factor, definitely the remainder is 0. So just equating it with 0, you can find the value of the unknown in the given equation.